Okay, so we're just going to do what this stack looks like implemented from Java's own version of the stack, and then we'll do something off topic with Java stuff. Since we'll technically be done, so we'll do a couple of extra topics that'll be good for you to know, going into next classes, and then for the last at least the last class, but probably for the last two classes, we'll just do a review because why not? It'll maximize your chances for doing better stuff. Why not? Okay, so the last thing is how a stack works. I know that in here there is a program that is, while it is interesting, as much as I was reading it, I was thinking like it makes something fun happen, but it doesn't make understanding a stack super easy. So we'll take this, I'll load it in, I'll get rid of most of it, and all we'll do is we'll populate a stack with push, and we'll depopulate the stack with pop, and then intermittently we'll do a push pop, and you can make a guess whether it's going to be, what the outcome will be at the end. Because we know that the stack goes in so that the last element put in is the first one that can be removed. So if you do A, B, C, D, D is the first one that you would, if you issued the command pop, D would pop off. Okay, so the last one in is the first one out. And then if you pop D and then push E, D would be removed, E would be added at the end, so it would be A, B, C, E. So we'll do something like that just to give everybody the knack for it. This does do something fun and interesting, but the fact that it reverses the message and uses nested while loop stuff, it obscures the whole point of first learning about the stack. So we'll just do it more basic. Look at it. We'll use something. Okay, so let's see. So from the beginning part, before I copy the rest, let's see if we're going to keep all this stuff. So enter a message. So we'll keep enter a message, and then message equals scan that next line. So we know that uh, takes in our thing as a complete string. So let's leave that, and let's just say we'll figure out what the output's going to be after we change our program. Sure. Okay, so we have that. So let me get. Okay, so let's look at all the rest. If it seems like you get what it means, then we can go with it. But I think we'll at least comment it out and just add pieces in, because essentially what it's doing is it's taking the string and then using the caret function to go character by character, and then simply just pop each element off. Because a string is a string. Like in other languages, a string is really a character array, so you can just take the string and then pop from the end of it. So if your string is 1, 2, 3, 4, 5, and the last element was 5, if you issue pop 5 times, it would be 5, pop 4, pop 3, pop 2, pop 1. And then 1 would be the last one popped off because it was the first one put in. So I'm going to comment this part out and then just copy some stuff back up and maybe we'll look at it. But notice that in this while loop, all that's really happening is that it's saying, while the string still has a length to it, do message caret index. So let's just take message caret and look at what it does when we place it to our string, so that we see precisely what it does inside that loop without having to go and understand it with all the strange stuff. Okay, so everything is commented out. So let's just scan the string view. Okay, so part of the loop basically said carb message caret index. So caret is simply a way of getting the character at a certain index in our string. So let's find what we have. So this is where it's looking for building up the stack using string, pushing each element onto the stack, because when we first get it in, it's a string. So it first has to be converted into a stack and then reversed. So that's why it's not as great as a stack analysis. So I think actually what we're going to do is let's just make a stack and push pop it, and then we can leave this for maybe next time, because we're going to do Java cloning, which is an important topic you need to know. And this is great, but the book that I got it from, I do, after years of using it, I understand that the professors who wrote it like to write fancy schmancy programs, but they're not easy to see what the basic element was. So let's just do the program. But if you are going to look for it for yourself, and we'll look at it next time, all the while loop does is takes the string, it analyzes how long it is, pushes each element onto a stack, and then pops each element off so that whatever the string was forward, it gives the answer backwards because it reverses. So that's all the stuff that goes on there. For us, let's just make a nice stack at it element by element. So let's see, we've got our stack, right? So the stack is already made here. So let's in fact get rid of, let's comment out, and actually just, I'll just remove all this stuff. We're not going to use it. So, let's see. Just want to see if there's any other stack you want to use. All right, so word.empty, so that's a stack. That's a stack function. You know, just like we did is empty, that's word. That's the same thing with the stack. So is the stack. So it's got push, pop. So word is the name of the stack. I'm just looking for any other methods that are used. I don't think so. I think that's it. So we'll use that same stack word, but we'll just use our own stuff. Because in the beginning, just like with the linked list, we want to just look at what a stack is. Let that sink in. But we'll only be implementing using the generic. We can do it with the long way like we did with the linked list, but we'll stick with just this to discuss how the stack works. So we've got our stack named word. So if I type word here, I type period. So we've got add, all this other stuff down here. So let's look for the methods we might want to use. Okay, so we've got pop, push, we've got peek. Peek lets you look at the first element without actually removing it. So that's what peek does. So let's just take those and then add them to the stack and see if we can take a look at our stack by printing out the stack name like we did with the generic linked list. Remember when it came out with square brackets, or do we have to use the group to print out each element of the stack, or do we do both? So if you remember from the linked list version, that was the generic. I think that it was get index or something like that. Let's see if there's a get index for it. There is. So we'll probably be able to do the same thing if we wanted to print out our stack in a specific form, but I'm sure that it's got a two-string. I'm sure because I've tried. So let's do push, and then let's try to put on just 4. So it says, okay, so it says word.push 4. So by saying word push 4, let's see what it does simply by printing out word, and let's see if it did anything. Just to try it. So let's see our print statement. Here, it's there. We might use this. Okay, so 4. So it does look like it uses the same square brackets to print out our stack. So let's push on 1, 2, 3, 4, 5, and then let's print it. So remember that printing it is not the same as popping, because printing it is just saying what is the contents of the stack. It's not going to say reverse necessarily. Let's just see how it works out. So we'll do 1, 2, 3, 4, 5 with 5 separate machines. So we've got push 1, 2, 3, 4, 5, and now we'll print it out. Let's see if we get 1, 2, 3, 4, 5, or 5, 4, 3, 2, 1. So we get just the list because when it prints it, it's not popping. The stack is still there. So now let's issue. Let's do push 5 times, and then let's do 2 pops. And pops don't take a parameter because there's simply a command that says pop off the top element. And then let's print it again. And let's see if we get 1, 2, 3, or do we get 3, 4, 5? Where is it going to come off? So stack is first in, last out. So the last one in was which one? Bronze. So if we do push 5 times, what's the last push command in the list? Which one is the last one? From top to bottom. Yeah, what does the last push command have as its number? What's that? So you push 5 times. The last one on the list before the print statement. What is it pushing in? Which number? 5. This is simple stuff. So don't overthink it. Like this right here, what we're doing would be very simplistic. So I just want to like get this out and then go into array. So it pushes 1, 2, 3, 4, 5, and now we're going to pop. So since 5 is the last one in, it'll be the first one out. So if we do pop once, the list should then say 1, 2, 3. So let's just show that, just to do one pop now. So we'll do. So we'll print it when it's already first made, and now we'll say pop. Now we'll print it again. So we pushed on 5 elements, we printed it, we popped once, it took off the last element, and then we printed it again, showing that it removes from the last one in is the first one out. Easy stuff about stacks. That really is all there is to it. So let's leave this as it is, and then we'll revisit with the program that is actually in the lecture maybe, or if I can find one that's just a little more, but maybe not so like loopy. Because the main thing is just to understand the aspect of the push pop. So if we had done like push with a pop after every single one, then the list would be empty. Because every time you push, it would pop one up. So the amount of pops matches the pushes, the list is empty, and it will go from the last node. That's the most important part of it. So let's go into look at Java. That's the more involved thing that we're looking at today. So I will make I'll make a slide with this one on it. First. Okay, so what is array? So I mentioned last time that arrays are, you can say, array A equals array B, and then whatever an array B is in array A, but it's really that array A and B are pointing at the same array. So we're going to look at the clone method, which allows you to clone a primitive array, like really clone it very easily. But then if you have an array of objects, we'll go through like a few different programs to show that. You can clone the array, meaning the 2 arrays are actually separate, but each socket still points at the same object as the object. So we'll do it stepwise. And if we extend into Thursday with it if we sent you what it looks at. Yeah.
Just confirm something. Push makes it go out, and push makes it go to the end, and pop takes it out. Correct?
Right. Yeah. Push makes go to the end. It's a description of what push does.
All right. Thank you.
Okay. So these programs I will be I'll post up once we get through them, but we're going to start with a slow look at it. So who knows who likes the Star Wars prequel movies?
The Star Wars what movies?
Prequel?
Jack, don't you remember?
I've only seen the
Well,
older ones.
the prequels completely destroyed the whole meaning of the Force, considering it was just the light side and not just the light side dominating everything.
But it was still Star Wars. So, right. So obviously, I'm just gonna have to go ahead with this. So, if you remember from the Attack of the Clones movie, the planet where the clones were made was Kamino. So, I named the classes that make all the driver classes that make the clones are named Kamino, and then I made the class that actually gets cloned from Jango Fett, who is the person who is cloned. So hopefully this will have you like the movie a little bit better. I admit that they weren't like amazing, but still like well, from having first seen them in 1977, nobody ever even thought they were going to come out again. So it's pretty good. Okay, so here's the deal. Also, one thing I would need to do is I need to make this a whole lot simpler for the first ones. Just this. Just okay, so now it's very simple. So the first one we're going to look at is simply a regular array. We won't even use this class. The second one we'll look at, we're going to make an array of objects. So that's when we'll actually have to touch this. But I took those other things out because those are for doing the cloning of the objects, which will be extra. So we'll add those in. So the first one is simply just a regular array. So this we kind of mentioned it another time. So we've got the array called data and then an array called backup. And then we just say backup equals data. So that means that they're both pointing at the same array. So they're not containing their own elements, they're pointing at the same thing. So if data changes one of the elements or backup changes one of the elements, they will both reflect the change. So we print out both arrays, we should see that. And then we say data 0 equals 4. So data 0 is 2. So if you change it to 4, it's going to change in data, and it's also going to change in backup because they're pointing at the same array. And then down here, backup 7 equals 888. Let's just see. Then we're saying that element number 7 of the backup array, so 1, 2, 3, 4, 5, 6, 7, has been changed to 888. But since backup is also pointing at the same array, that should also be changed for data. So let's see if that's the case, just to show that setting one to the other is unlike primitives in that they're pointing at arrays because arrays are objects. This arrow is going to pop up. It's just from that placeholder class I made. It's not for whatever. Okay, so we changed data 0 to 4. So this changes to 4, and then it changes in both because they're both pointing at the same array. Backup number 7 was changed to 888, so 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. This is changed to 888, and then it's reflected in both because they both point at the same array. So for a regular primitive array, this is easily solvable problem. You just use the clone method, and it will clone immediately with a single line of job. And then this won't happen because they will each have their own individual array elements. So this is the easy one, but array cloning is really most talked about for objects. So if you just say data.clone, meaning the original array, clone it to whatever you're setting it equal to. Now they both have their own array. They're not pointing at the same thing. And this up here, I'm not sure. Let's see if we need it for the clone method. We do need it for the array too. So we don't need it for the clone method, but we still need it for the array too. You'll notice that within the program I use this thing that says arrays toString to print out the arrays. It's a very quick way of printing out all the array elements without having to do a loop. So it's just faster. So data.clone will take your array, clone the whole thing. They'll both have their own separate thing. So now data 0 is 4. So data has 4 there, but now backup will not because backup has its own thing. So backup's first element will still be 2. And then when backup changes the last element to 888, it will change for backup but not for data. As we see, because between this step and this step, backup equals data.clone executed. So data has its own individual array, backup is unaffected. Backup changes the last element, but data is unaffected because it has its own individual array. So for primitive arrays, it's very simple. You just do the array name .clone from the Java library, and it works. The thing that you have some extra implementation is when you need to clone arrays of objects, and then when you want to actually clone each object in the array, because just to clone the array is, well, you'll see that it's like it does something, but it doesn't do what you would expect it to. It makes well, let's look at the example, and let me see if I can think of a better way of writing this. We can start first. So, okay, all right. So I'm going to write this with a marker so that the concept comes off a little bit. Okay, so say that we have, say data and backup have objects instead of primitives. So data, backup, and let's just say they have 2 elements. So this has got object 1, object 2, and then this one is size 2, so it's very size 2. So we set this one equal to that one. We say backup equals data, and we can't do that with objects. We have to use the clone method. So if we execute backup equals data, what it does is it does make individual arrays of each of them, so that data has OB1 and OB2 in position 0 and 1 respectively, and backup will have the same thing. So if you have two object arrays and you issue the data.clone command, but you don't do a full cloning process, each of them will have their own array elements that still point to the same objects. So here's how that is different than them having not their own arrays. Say if we said, backup, let's say backup 0 equals, however the code would work. Backup 0 equals OB2. So by cloning the array using a one-line clone method, when you're doing an array of objects, you allow it to actually change where the array elements are in one array. So backup will have OB2, OB2, data will have OB1, OB2 still. So in that sense, it allows them to be separate arrays, but they're still pointing at the same objects, meaning backup is pointing at OB2 twice, data has OB1 and OB2, but they're still pointing at the same actual objects. The objects themselves are still sitting in a array. So, it's like you have to conceptualize differently than the primitive. The primitive, it was either they both pointed at the same array or they had a separate list because primitives aren't objects. But with this, when you use the clone command, you get data having a separate array. So think of the array as like two pointers that are pointing at the objects. So data is pointing at the objects, backup is pointing at the objects. When you clone it, it allows you to change the pointers around so that you can point at anything you want. But if you change one of the objects, as we'll see, then both of the arrays are affected because the objects themselves have not been copied. Just the ability to place them in different locations have been copied. So if you printed out a backup array, it would print out OB2 twice because you said make position 0 have OB2 in it. And data will still have OB1 and OB2 because its index values aren't affected by what backup does. But if backup somehow erases this object, they will both not have that object to point at it. So a real clone is to clone the arrays and then clone each object recursively using it. So let's look. So that's the reason I did this using just two elements and a marker is to get you to understand that when you clone the array, you're cloning the ability to switch around the indices for each array, but then the objects are still pointing to being pointed at from the same in the same memory space. The objects haven't been copied. This way, objects aren't copied yet. We have to do a bit more. And we'll do that by demonstrating that the objects are in fact the same. Okay, so looking at the third version. So the third version now is going to make use of the class that are telling the clone through objects. So with this one, the array only has 3 elements, so it is pretty simple like the one we just did. So we're going to have this array that's going to have 3 objects in it. Copy 1, copy 2, and copy 3. they're objects. So, for the moment, that's the important aspect. And then we're going to, so if you don't use the clone, the array itself isn't even cloned. So I did this all like super step by step. So the first way is we looked at the primitives. So this way, each of the array indices are also not copied. So it will be the most elementary C for us to look at. So we'll have fed array 1 will have copy 1, copy 2, copy 3. This one will just say equals this array, so they will be pointing at the same objects, and each index will also be the same. So we're going to say fed array 1 element 0 equals copy 3. So this array element 0 equals copy 3 means that this array will have copy 3, copy 2, and copy 3 as their elements. And then we'll be looking to see, is this one affected by that index change? Because, as I said before, when you use a clone, that would be the case. But here, we'll look at what the outcome is. And we'll go, slow enough that it's absorbed. So it's like, I want to do this so that everybody's on the same page. So we'll stay on the individual comments as long as so the point here is going to be to show whether or not each array's index change can affect the other array, not whether or not the object is being erased or not. The objects in this program are just left alone; they're just shifted around. In this particular. Okay. So we printed out both arrays before anything happens. They both have the same elements because we said fed array 2 equals fed array 1. They all have the same stuff. So now down here we look and we see, let's just look for a difference. The difference between this and the top is what? This one to this one. What's that?
The numbers. I mean, the age. I think the age is different.
Which one?
The ages are different.
Which section?
What?
What?
No, I just I think the first section, like the ages are different.
So this one and this one are different than this one and this one. So it looks like both arrays were affected identically in the second printout of the arrays. So let's look back at the program and see which command was executed to get this changed so that we're understanding that since we didn't use the clone command, the index values are also still common to both arrays. So without using the clone command, they both point at the same object, and then also each index value is identical. So when you change index value of array 1, index value of this one is also changed because we haven't done any cloning at all. So let's take a look at what command was there. So it says fed array 1 0 equals copy 3. So that's why copy 3 is over here. So it was brought over to this one, but since fed array 2 also is identical with that, that also will show copy 3 being in position 0 because we haven't done any cloning. All we did was this. So when you set one array equal to another, whether it be object or primitive, if you don't use the clone command, each index is common to both. So if you change one index in one, you change it in the other.
Professor, is the Star Wars posted on Blackboard?
These are. I wanted to post them after class because we wanted to maybe change them a little bit, and we probably only get through like 1 or 2 programs, so I wanted to just wait till then. But I'll post it after class. Okay. So then, similarly, we changed array 1. Then we also changed array 2 by saying whatever was in position 3, meaning position 2, 0, 1, 2, put copy 1 there. So we know that position 3 previously had copy 3. So now we're saying for array 2, put copy 1 there. So we should see that both array 1 and array 2 are affected having copy 1 placed there because they both share common index values and they both point at the same objects without using the clone. So you see from our execution of it, we see this right now. So in this place right here, we said that array 1 position 0 equals copy 3, and then it affected both array 1 and array 2 because they both share index and share objects. So now, if you look at this, once you do that, there actually isn't an instance of copy 1 in any of the arrays. There's only a copy 3, a copy 2, and a copy 3, but remember, we made the objects up at the top of the program, so they're still floating around in memory. So we can still use copy 1, which we do down here. So this one, it said fed array 2 equals copy 1. So then they're both affected because copy 1 is placed in the 2 index position in 3rd place, and they both have that chain reflected. So the point for this one is, just like with the primitives, when you do not use a clone command, you will be making the same identical array, both indexes, and then once we do use the clone command, we'll see where the difference splits out when you're doing arrays of objects. Because with arrays of primitives, when you use clone, it's all done. Like you have an exact clone, you can change the numbers to whatever you like, nothing's going to happen. But when we use clone on an array of objects, it will do something, but not everything. So now we'll look at the version that uses. Okay, so we've got a slightly new version. So notice that this is, I believe this is identical to the one we just did. So yeah, it's identical to the one we just ran, except that it uses clone when it sets array 2 equal to array 1. So now, if this was a primitive array, they would both have their own separate stuff and it would be great. And it will do that to a degree, but we'll show how it doesn't do to a degree in the next one, if we get there. But I want to stay with this one to make sure you get the subtle point about it. So here's going to be the deal. When this makes a clone of array 1 into array 2, it's going to, the objects won't be cloned. So copy 1, copy 2, and copy 3 are still just going to be one instance of each. But each array is going to have its own index values that they can independently change. So by just using one array, let me see if I can write this out. So if after you do the clone command, you were to write that array 2 equals something, when you change what's in the index of that array, you change it independently of array 1, because you can think of each of the indexes as like boxes. So like that array 2 is a box that holds copy 3. So copy 3 lives in fed array 2 and in fed array 1 position in the second position, third position in the array. So if we change this to hold copy 2, then that one will be changed. So fed array 2 will be copy 1, copy 2, copy 2 again. Fed array 1 will be left to 1, because each of the individual little boxes, you can change what's in them. But then say on another line, which we'll do in another program, if we somehow deleted the object copy two, then both of them would have a null object in them because the objects are not copied. Only the array indexes are copied. So originally, like you'll have two arrays without using clone, they'll be pointing at the same objects, and actually each of their indices is also identical to each other. When you use array one.clone with the object array, you allow the two arrays to have their own indices that they can manage. So if you change index value 0, what it holds from the other one, the other array won't be affected as to what its index value 0 holds. But if you change the actual objects that they hold, that will affect both of them because when you issue the clone command on the array of objects, the objects that they contain are not cloned yet. So there's still just copy 1, copy 2, and copy 3. So if we delete one of them, both of the arrays, even if you shift it around where they were, they will reflect that that object has been deleted because they haven't had their own separate copy of the objects. So that's what we'll be looking to do by looking at this one a little bit more, and then I think we'll probably leave these the ones we've done to go before the next time because array cloning is important to know before you do data structures. So it's important to understand. Yeah.
So that clone, is it like a built-in method?
It is.
So I mean, I guess just to clone it, you can just do array one equals array two array two equals array one dot clone. Alright.
And then you clone the actual, like if arrays were like, boxes with multiple slots in them that held stuff, you would clone those. But you don't clone the stuff that are in the boxes. That you have to do an extra step, which we're going to do in the next video. So for this one, what we'll be looking to see is, so notice we say change array 1 element 0 to copy 3. So array 1 element 0 change to copy 3. When we issue that, this should change to copy 3, but then it should remain unchanged for array 2 because while the objects themselves aren't changed, the ability to say where each object is placed in its list, that is separate. So when we make that change just for array 1, array 2 won't be affected because it has cloned the array structure, but the stuff in them, not cloned yet. And likewise, when we issue array 2, position 2, put copy 1 in there, it will place copy 1 in this position for array 2, but array 1 will be unaffected because they both maintain their own sequence of where the objects are, yet they're still both pointing at the same objects. So wherever they are doesn't matter, but the objects they are pointing at are still shared. So we'll be able to demonstrate that next time by deleting an object, and you'll see that they both have reflected to them. So you'll see that they're really not completely cloned. They're like the array is cloned, but not the stuff. So when we do this, unlike the last one, so the last one, remember, the deal was, so before we use clone for the object array, we had, so this is no clone. Two object arrays, we had array 1, position 0 changed, and then it reflected in both. And then array 2, position 3, position 2 changed, and it was reflected in both because they both point to the same objects and they also have the same indices in common. So if what's in an index changes in one, it is changed in the other. So the two parts of an object array are what is held in a particular index. Index 0 in this case holds this object, and then which object is it point to? Does it share an object with this one, or does it have its own object for itself? So right now we saw that the index is mutual without the clone command. And now when we run this identical program with the clone command, we should see that when we see this one run, only array 1 should be affected because it's not issued on array 2. So this array element is managed by itself, this array element is managed by itself. So this will change this one. And then here when we say change array 2 position 2, this one will change, but this one won't, because each of their indices are managed by themselves. The clone copies the index for each array and at least sets it up so that it's ready to have copies of the objects. So let's look at that. Okay, so we saw, so now this is different. So array 1 index 0 is changed, but it's not changed here because the clone command set up this and this to have their own separate boxes in each element. What goes in them is still shared. So for example, this and this and this and this and this, they all point at the same object, like 4 places pointing at the same object. And then here we changed array 2, element 2. So it was just changed for array 2, but not for array 1, because their indices are now separated from the clone command, issued on array 1 dot clone equals array 2. So this is the next iteration. So the next 2 programs, which we'll look at next time, first we're going to see how to delete an object, which maybe you've seen before or not. So we'll delete, say we'll delete this object, copy 1. So if we issue delete copy 1, if we printed them out again with no other changes, we would see this null, we would see, that's it. So this would go null, and then all the rest for ourselves that they do indeed point at the same object still. And then the very last program will be copying the array structure and then copying the objects into each array. And then if we delete this object, this one will be unaffected because it will have a copy of the object in there. So for that, it would be, we have to implement the clonable interface, much like, well, similar to implementing the comparable interface, so that we can do a clone operation on the array first and the objects iteratively as well. And we haven't shown. So I'll upload, so we did these first up to 4. I'll upload the last 2 programs too, so that you can look at them. So we'll do that next time. And I believe Sanchita's got some exciting plans for you. Not sure what, so we should leave it for suspense. So I'll upload those, and also if you came in later, we're going to do this now, finish it next time, and then next week is 1 class. I think Thursday is study day, one of the days. And then the week after, there's a day, and then there's the final. So we'll have, next week we'll do review on the Tuesday, we'll do review the day before the final. So we'll have a lot of review. I do encourage you to attend the review classes because I'm sure I'll drop inadvertently some hints about it.
And also, do we have like a practice quiz?
It'll be just like the midterm. So
Okay.
I'll be giving you the prep sheet. You can bring anything you want, it's just not electronics. But for people who didn't bring the prep sheet or brought it like, submicroscopic, print it so that you can easily see it and bring it. Because just like the midterm, if you took every question and held it up to every page in the review, you would find the answer. So bring the review sheet and have read it so many times that as soon as you see a question, you'll know exactly where it is in the review sheet. Like even if you don't understand the concept, you'll be like, I've heard of that on page 20, and then go there and then figure it out. So plan to print the review sheet.
Is the review sheet already on Blackboard?
No, I haven't made it up there. Because I still have to get some of the common questions that the department mandates to include, so I have to include review for those in the review sheet. Okay, so that's that for now. But array cloning is a important thing, and hopefully this will be fun and enlightening. But each of the programs changes it very slightly, so you should be able to piece your way through. But we'll do more of a review on Thursday. And I shall be at office hours for your questioning purposes. Thank you. So please stop by if you have any questions about anything. If you need your midterm, I didn't carry them, so decided to not carry them anymore. So they're at the office for one week. So stop by.
Thank you. So what is the professor covered in the last 2-3 weeks?
So he just covered the cloning arrays. Small thing. I don't know.
Lists, sorting, searching.
Did it link this?
Yeah, briefly though. And
Okay. Is there anything specific that you want me to cover?
I was going to ask you about the, well, basically linked lists and like nodes and stuff like that.
Oh, yeah,
I
nodes.
understand them. And then the thing that you posted on SciBooks, I understood the sorting one, but then the one that was linked list, I can't seem to get it to work. I just have a ton of errors all throughout it. So you
Okay.
can explain that thing.
Oh, you know that lab that you posted on ZyBooks?
Yeah.
Can we do it together?
The duplicates one?
What?
The duplicates one? I did the.
That insertion sort one that you put on.
The link is one, right?
Yeah.
Removing duplicates.
Like if we can do that lab together, like as a class.
Okay. Oh,
I think so.
Yeah, but we had.
Oh shit, I have trouble putting
But it helps.
Oh my
Let's do-
god. Holy shit, yo. What's that?
It's a big, it's a big one. This is my YouTube channel. You Yeah, I'm getting more watch time. I get like I'm getting like a call like 2 hours watch time, and then I've also got
So talking about why we use linked lists, one of the main things that distinguishes an array and a linked list is that linked list can be stored in multiple locations in your memory as opposed to an array. So if in my memory I have an array of
an array of an invisible X.
there's not
Is there a black marker?
I don't know why
It's kind of weird because like red catches people's attention more.
Yeah, it does.
doesn't work.
But if it doesn't work, it doesn't catch anyone's attention. Well, other than the fact that we see it's not working.
I Do you know where I can get a marker from?
The other room?
Admit.
Oh, we can borrow one from one of the professors.
Can you?
Or we can try.
Please go.
What?
Can you please go?
I'll try.
Try next door, like right across.
Alright.
How about a MS Paint?
MS
Yeah.
Paint, that's amazing.
Generally, is it better to use linked lists as opposed to array lists? So like, what's the situation where one is more preferred, or is that depend on something?
So I think when you have nodes that you want to access without having to care about the index, so in linked list you can't just access a node that you have at any given node.
Try checking other rooms, maybe.
What's happening?
So,
Look, I meant no harm.
Gonna sell my cookies on the black market. What? Hell yeah.
Yeah.
Okay, somebody know to notice.
what did she not say?
What was that?
I don't know.
I was
Yeah, it's just like.
No, no.
I mean,
We got it. Let's see.
I gotta go to art school in Manhattan. Figure it out.
Go ahead.
So, let's say I have an array of 100 elements. In my memory, what I need is the entire array to be together, and I need a free space of 100 blocks that is available to me. So if this is at my 0th location, this has to be at my 1st, 2nd, 3rd, 4th. So I need to have that 100 block of space available for me to be able to use it. In linked list, it's different because I don't need them to be together. I'm simply linking them. So this could be at 0th location, this could be at 5, this could be at 2, this could be at 4. And because I have a link between them, I can access them irrespective of what position they're at. But using linked lists, I don't have any specific way to index them. So when I say A of 0, it gives me the exact value that is at the 0 position. I cannot use that with linked lists. So both of them have their I would say pros and cons, and you use them for specific problems where, I mean, you would use the linked list when you don't have to access something directly, and if you need to access something directly, linked list would not be efficient. So if in my linked list I have equal number of array elements, and I want the last element, I would have to traverse the entire linked list as opposed to just finding the last element. So basically, that's the main difference between an array and a linked list. And so let's talk more about what goes inside a linked list. A linked list is a node with the value that I have and a pointer to my next node. So this entire thing is a node. So when I'm defining my structure, I have a class node. Inside that, I have an integer value. This stores the value of what is inside my node. What I need again is a node next. This next is my pointer to the next location that I have. After that comes the constructor. So So whenever I'm saying that a node n equals new node, that's it. So what is happening when I write this statement? It's going to my class node. It's creating an object n of my class node. And since I sent 4 in the constructor, what is happening is that my value is now 4. So the value part of my node now has 4, and I'm saying it should point to null, because that's how I've defined my class node. So that now it's not pointing to any other location. So let's say I have another node. Now I have another node in my memory with the value 2, which is also going to point to null. Because I also have something called as node next, this is a pointer to my next location, right? So if I say n1 dot next equals to n2, this means that instead of pointing to null, it's now going to point to this. So now there's a link between these two nodes, and that's how a linked list works. So what I'm doing is I have my class node. The only 2 elements that I need inside my node are my value and the pointer to the next location. The pointer to the next location is also a node. Okay, so it's important to understand that when I'm saying n or n2, these are just references to a node. The value can only be accessed by saying n.val or n2.val. So as long as I'm saying, I'm trying to print SOP and say n, this is only a reference inside my memory. So I won't be able to get a value of this node just by saying, okay, give me the value of n. That's not how it will work. The value is stored in a specific integer called value. It could be named anything. It depends on how you define your data structure. So you would name n.value or n.value or whatever your name node is. So this, when you're creating this, you're just creating a pointer inside your memory that you can access. and you use that to access the value and the next value of it, next pointer of it. So when I say node not next, I'm saying that there is also a node, and I now want a link between them instead of it just being.
So when you say system.out.print and you're actually putting an n2.value, or
So if I just say this, it's not gonna give you the value of this,
Right.
what's inside it.
Right.
Because n is just a reference. When I say n.val, that means I want the value inside this. This entire thing, this entire structure is n. This is n.val, and this is n.next. There are two components inside my node, which is value and the next. So when I say n, it's just a node, which is just going to give you a memory location of that node when you say print n. What you need specifically is the value.
thank you.
So if I have, let's say now this is my linked list 1, 2, 4, 2, and in my linked list there needs to be one entry point inside my linked list, which is how you define the head. Like I said, you can't directly access this value inside a linked list, like the second, third, or some nth value that you want. In a linked list, you only have access to the very first value of the linked list, which is called as the head. The head is your entry point inside the linked list. So as long as you have a head, you have access to the rest of the linked list. Okay? So now with my class node, I can also have a node head. But just for like good practice sake, I wouldn't recommend that you do this, because let's say in my main program I said head is going to be the node that has the value 2. And then somewhere else in my program I try to access the value of head. Because I changed the value and some other line of code was trying to access the same head value, there's a lot of inconsistency between head, and head is a very important part of your linked list. So if you change the reference to head and it doesn't reflect through your linked list, your linked list can easily be lost. Because this is your only entry point inside, you have to be very careful with this. So a better way to define a linked list would be to use a wrapper class. And all of that comes in. So just by doing this, I'm making sure that head stays a member variable. So any change now made to my head will reflect throughout the linked list. So if I change my head at this point, it's going to reflect throughout. So now if I say that instead of 1, I want my head to be here, this is easily lost. This part of my linked list is lost. And now my only entry point is here. This ensures that there's no consistency in your linked list and that your head will always remain whatever you need it to be. So however you modify inside in your main program would reflect throughout your linked list class, as opposed to how it would act if your head was defined here. So this is not recommended. A better way to define a linked list would be using this, where you keep your head outside your node class. So any change made to this reflects in your entire linked list. Okay. Let's talk about traversing a linked list. Does anyone like this one?
Is there an instance that you want to continue changing the head?
No, but if you're trying to make changes or when you're specifically, you're making your linked list for the first time or when you're trying to delete some elements. It could happen that you want to change the head. Let's say I want to delete some node that has a value of 1. And what if the value of head is 1? So I need to delete that. But I also need to make sure that my head changes to the one after that, so the entire linked list is not lost. This being my linked list now, and given that this is my head, my linked list now has 5 elements. Let's say I want to print all of my linked list elements. What I would do is create a new node, a temporary node, and give it the same reference as my head. So now I have another pointer that's called temp, which is pointing to the same location as my head. And now I'm saying that while temp.next is not equal to null, while temp.next is not equal to null, I'm printing out the value of temp, and then I'm saying temp equals to temp.next. So now that my pointer is here, the first thing I'm doing is that I'm printing the value. So 1 was printed. Then I said that temp should be equal to temp.next. Temp.next is right now this, so it's pointing to this location. So now instead of my temp pointing here, this is where my temp is going to point now. Again, inside my for loop, I print the value of 2, and my pointer changes from here to here. This should go on till the next of some pointer is equal to null. That's where I'm going to break my loop. So it shouldn't go on infinitely, but whenever temp.next is equal to null, it's just going to stop, because now I know that my linked list has ended and there are no possible values after that.
Sorry,
If I just said, instead of making this temporary variable, I just said what would happen?
So then, I guess head would go to 2, and it'll stop there.
So this would be my new head. Would I still have access to this inside my linked list?
No.
So that is why you need a temporary variable, and you give it the head value. So you're not modifying the value of head, and you're not changing anything in your linked list. This temporary variable allows you to traverse your linked list without making any changes to head. But most of the times when you want to traverse your linked list, you have a node that starts from head. Okay, let's talk about inserting linked list. let's talk about deleting first. So let's say I want to delete this specific person whose value is 4. So I start traversing. And just saying while temp.next is not equal to null. I'm seeing if my let's say I want to add something to my list at this point. This is what I want my new linked list. I'm starting from here. I'm saying while temp.next is not equal to null, which means that I'm traversing till my last location, and then I'm saying I want a new node to be added. So the first thing I do is I create a node. New node. With a value of 6. Now this node has been created in memory. Till I traverse, till I reach my 5th node. This is where my temp is running. And I want to attach a new node at this point. What I would do is, since temp.next is now null, I just say temp.next should now be equal to this name. By saying this, instead of this one being null, I created another linked list. Let's say I want to add an element to the very first position. So that would require me to modify my head. In that case, the first thing that I would check I will create a new node. With the value of let's say 0. And I'm saying that new head dot next should be equal to. What I'm doing here is that this node that I have right now in my head should now be assigned. So what's happening in memory is my node of 0 is now connected. But for this change to make any difference, I also need to change my head. So now I say head equals to node. Now I'm saying that the head value of my linked list should now be this instead of this. If I swap these two steps, my linked list is going to be empty. Because I created a node I said the head should be new head, and then this entire link list was lost. So the first thing I need to do is make sure that there's a node behind my head. So by saying new head dot next equals to head, I'm making a link between this node and the head node, and then I'm changing the value of my head. This makes sure that my head stays my link list stays intact. If I want to insert a node, let's say somewhere in the middle here, at maybe the third position. That's how it works. So I equals to 0, I less than 3. And my node that has the value of head. Since I want to insert something at the third position, I started a for loop that travels till this. And now this is the location that I have right now for my temp. I want to insert a node between these two nodes. This is temp.next. And this is my temp. So the first thing is to create a node of the value that I want. So a node with the value 7 is created. Now I want to make sure that temp.next should go to this place, go to this node instead of this node. But if I do that before I do anything else, this is directly going to point to this, and this currently points to it. So I will lose the rest of my request. So before doing that, I need to make sure that this node first needs to point to temp.next. So n.next, which is right now null, should point to temp.next. By this line, I'm making sure that instead of pointing to null, this now points to 3. Now I can say that temp.next should be this. So temp.next equal to n, which means that instead of pointing to 3, 2 will now point to 7, or to this node. And that's how I would insert something in the middle of my list. program covers most basic operations of my list. I have my linked list data structure. Inside my main program, I created a new linked list. I assigned my head, I put in all my values. I created a link between them, and then I have my methods. So we did insert and middle, and this was given a particular position. Like I explained, I created a new node, I created a link between them to insert at the last position, to insert at the first position, print all of the values.
Is this going to be posted on Blackboard? I mean, is this on Blackboard?
I could send it to you.
Alright, thanks. It's email time again.
Whoever wants this program can take it for example.
Alright, I'm just gonna send it on Blackboard then.
Talking about deleting a node inside my linked list. Let's say I want to delete a node at the third position. Deleting a node is not as easy as inserting, because in a linked list, as you might have noticed, you only have a pointer to your next node. If I'm at this node, the only way I can move is this way and not this way. So I lose the pointer to my previous node that I have. But in order to delete, I also need, if I'm saying that I want to delete this particular node, I need to make the pointer of this node point to this node. For that, I need a pointer to this node before I make any change. In that case, what we do is I have my temp, but I also need to have let's say both of them point. So this is my head. It's also my temp. And previous. So when I'm moving forward in my loop, I use the for loop here. So I'm saying temp should now point to the second one. So instead of temp being here, it's not going to be here. And my previous should be 1 before temp. So nothing happens to my So every time this moves, when temp comes here, before temp moves forward, I'm saying previous should be temp. And currently my temp is here. So my previous changes from here to here. Since this is the node that I want to delete, I have a pointer to my previous and I have a pointer to the next. So once I know the value, I reach the node that I want to delete, I can say that this should now point to this. So to be able to access this node, I need temp.next. And I want to assign it to previous.next. So previous.next equals to temp.next means that this is now going to point to this.
So then like
Yeah.
it skips over one of them.
So because I can just change a reference to it, there's just no link to this. This node still exists in memory, but there's just no way to access it now.
So it still exists in the memory, but you can't access it.
So eventually, since there's no access to it, like Java will take care of it and delete it because no one's using it.
So garbage collection, I guess.
Yeah.
So it's not there then.
Yeah, I mean, you don't have a way to physically delete things in Java like you do in C and C++.
But what about the garbage collection? Doesn't that delete stuff automatically?
So since there's no way to come to this node at all now that the link has been severed, when your garbage collector is going through locations inside your memory, it knows that this particular node hasn't been accessed and there's no way to access it, so it gets deleted. Or what I did was I made temp.next equals to temp. So since my temp is here right now, instead of it still pointing to, I'm saying temp.next should now point to temp. So instead of this pointing to 4, it now point to temp. So this is like an independent node, and because it's not, there's no way to access it and it doesn't go anywhere else, so garbage collector will take care of it.
What is your name? Oh, today? Oh, you're applying for a job?
Yeah, actually a third job. That's like I'm two of them.
Oh, you have two now?
I've applied to two, but I haven't heard back, so I'm applying to a third.
You looking for a job in the summer?
Yeah.
Are you going to summer school?
I'm taking the summer class. Yeah, here and in the summer 2 semester. Like the one that ends in August.
So it's second summer session.
Yeah, it's like July, like mid-July to like late August.
So you're looking for a job for the first summer session.
Yeah, so I can get a bit of money.
So would you keep your job like in the second summer session as well?
I'll have to work that out with the schedule, but I think this one's like here. If it's in the city, then yeah, but if it's in Pleasantville, definitely no.
What would job are you trying?
Like most student positions, like a student assistant for like mostly in Seidenberg or ITS.
Like tutor?
No, not a tutor, no, just like helping out, like you got helping out. It's not like it's more like hands on, like kind of like customer service in some way. Basically, like you have to help out with like IT services, like help you with their one-page account activation. Also, they're like troubleshooting things, stuff like that. Another one I'm really hyped for is like web design. It's like a web design one that will be working actually with Dean Hill.
That's not the non-profit one, is it?
Well, no, this one is not for nonprofit. It actually has nothing to do with that AOK, but I am taking that next semester.
And then you also get field work for non-profit, don't you? Like,
What's that for nonprofit?
like you get field work there? Like,
I mean, you like community service? Oh yeah, I totally would. Like,
you get like $25, right?
I mean, it depends on how much you work per week. Because like, if you let's say you do a volunteer job, right? If you do the volunteer job, pretty much all your community service hours are covered.
I have to like get to the back.
How many? Do you have to get $25?
I'm not sure exactly how much. I'm a bit out of the loop.
I've gotten my community service done.
So what I did for my community service is work as a CIT at my local summer camp. Then I was a counselor for about 3 years, and yeah, I'm not going back this year. It just doesn't do that much for me anymore.
You don't get to count it like here, right? Like for the community service.
Don't think so. I mean, when you counselor to when you apply here, but like, no, like, you have to do something different. Take an internship or make it a volunteer position, and yeah, it totally works.
If you have an internship with kids, like a community service project with kids, like what I recommend is like if you like towards the beginning of your community service project, like if you spend more hours there and then like towards the end you won't have to spend as many, and also like not as many kids will be there anyways.
Well, I mean, it's not really just about the hours. It's more like you get to spend time with kids and really get to know them, mentor them, see them grow. So that's like the big part of it.
Right, but like what I'm saying is like towards the end of the school year, a lot of the kids aren't going to be there at the place where you're doing community service. Like only very few.
That's true, but what I'm going for actually, well, next summer, not this summer, but like summer 2020, I'm going to try and work at Camp Seidenberg holds for students with learning differences.
Oh, Tech is Unlimited?
No, it's not actually. I checked it out. I checked it wasn't Tech Kids Unlimited,
Is that
but
the one that Rosenberg?
I don't recall the name, but this job was on Glassdoor and it was completely separate from Tech Kids Unlimited. It was a Camp Seidenberg was holding, and to do that internship, you needed to take the CEIS 102W AOK. Or they said it was a plus to have it, but I'm still going for it anyway to raise my chances.
Oh, it's just a plus.
Yeah, or required. I really don't recall. Either no, I remember it's a prerequisite. Either way, it's still helpful nonetheless.
So you're working at the Seidenberg camp this summer?
And not this summer, but like next year, like summer 2020. That's what I want to do. What's up? Wait, what's up, Chris?
All my ones on
Chris, did you say something?
are not bad.
Yeah.
I have 26 subscribers on YouTube.
Well, it's like I missed some. Yeah. We're supposed to be working on this now? Are we supposed to be working on this now?
I don't think she's available now. Maybe it's gonna be live later.
When I'm done with that, kind of that attractive.
I think it might be better with that.
Alright.
And there's only 2 minutes left in class.
I'm not sure. I might as well pack up now.
Yeah.